It's called Under the Desk at MIT.
Thanks for coming to the talk. I appreciate it. What my talk is going to be about is a new group I'm trying to form called the Public Domain Software Foundation. And basically what this talk is going to be about is going to be about avoiding the whole world of licensing and legal matters and just sticking to code and getting to actually program instead of having to play amateur lawyer. So something I've been trying to do for years, but I'm actually trying to convince other people to go ahead and do it along with me. The reason my talk is called Under the Desk at MIT is that I recently snuck in the back door of MIT, and they haven't kicked me out yet. And when you do get to MIT, you have this kind of nagging, looming question of what am I going to do while I'm here? And so I kind of grew up on free software. I'm a little bit older than I look, and my first program was actually written, aside from BASIC and things like that in elementary school, with GCC in the 1980s. So I'm a huge fan of Richard Stallman, and RMS, if it wasn't for him, I wouldn't really be able to even be a programmer, I don't think. I never would have been able to get access to the compilers I needed, and back then a basic compiler cost over $1,000, which in today's dollars is probably closer to $3,000 to $5,000. So when Richard was developing the first versions of the GNU software, he was at the AI lab at MIT, and there were a number of times when he slept under his desk actually writing GDB and GCC and the other tools. It was mostly a one-man effort when it first came out. So I'd like to take a moment before I even start to just recognize his amazing contribution and thank him for it, because I don't think any of us, for the most part, would be here today without him. I'd like to go over a little bit of history, a little bit more than I already have, and that's that what really started everything was the commercialization of the MIT AI Lab. And if you were here for the keynote opening address, you got a better history of this from RMS than I'm going to give you, but I just want to briefly kind of cover it because I'm going to relate back to it throughout my talk. Basically what we had at the AI Lab in the 1970s was a situation where software wasn't really considered intellectual property at all. It wasn't something that was licensed or copyrighted. It was just basically like mathematics. It was something that was discovered and made available and basically committed to paper, to tape, or to any of a number of other mediums over the years. As the commercialization hit the MIT AI Lab, and we started to have competing interests between commercial software and this idea that software wasn't really something you could own, it wasn't actually property. The AI Lab had a schism, and there was basically a separation to the two camps. One that believed that software was property, it was something that was invested in and developed, and the other that believed that software was something that couldn't be owned and that it should be shared and freely available. That really culminated in the announcement of the GNU project and its beginnings in 1983 and 84 with, like I said, the introduction of GCC and GNU, GDB, the debugger, and so forth, all of the tools that are associated with that, and what eventually became the GNU plus Linux operating system. The GPL really took the lead in the early years, thanks mostly to Richard and the fact that he was the one leading the community. Over the years, though, as more people began to gain exposure to computers and start to write software themselves, they found they had different competing interests compared to what Richard had of just basically sharing things. They had grants they needed to fund, they had companies they wanted to start, and so forth. And different universities had different cultures than MIT, and we're also producing really great software. What we found was the BSD license came onto the scene, and that was the next really large license that took up a lot of what was available in terms of the actual source code, the number of lines of code available. If you were to actually go back and look at the number of lines under the BSD license and the GPL, you would see that the BSD license caught up very quickly to the GPL and eventually came close to surpassing it. As time went on, there was basically 2 or 3 licenses, mainly the GPL, the BSD. MIT had a license for a while that was pretty popular, but eventually kind of faded out and was replaced by GPL and BSD. Commercial interests eventually entered the subject area and the world of software, and that kind of happened during the dot-com boom when a lot of companies saw that they could do a very quick and low-cost startup by having software costs reduced by using openly available software. And we found the open source movement founded from that, Eric Raymond and so forth, actually trying to get companies to share their source code so that things could progress faster in general. Now, this led to a number of problems, most specifically license proliferation. And that's something I'm going to try and address in this talk, and hopefully something that the Public Domain Software Foundation can address. So what's next for the community of software developers out there, the people who are developing free software and who are working in this area. And hopefully, there's going to be a public domain component to that. Now, the two groups that are really opposed, as I said, and this goes all the way back to the days of the AI lab, is the people who don't view software necessarily as property and who view it as something that should be freely shared and available, that anyone should have access to and be able to study. And I kind of call them the freedom camp. And then the control camp, which would be the businesses that are trying to make money and develop a commercial ecosystem around software development and computers. Now, the freedom group, as Richard pointed out during his keynote address and through many documents on the Free Software Foundation website and the licenses, is that there's 4 primary freedoms that are of most importance. Freedom 0, the freedom to run the code; freedom 1, to study the code; freedom 2, to share the code; and freedom 3, to improve the code. The control group obviously has different interests. Their primary concern is investment recoupment. They pay a number of programmers to develop software, and they need to make sure that they can pay the salary and actually get a return on investment or repay the investors to continue their business model. They're interested in protecting trade secrets rather than actually allowing people to study the code. And they're interested in competitive advantages over the competitors rather than sharing the code. And likewise, a predictability of maintenance cost has a much greater concern to them than the ability to allow people to improve the code or what kind of benefits those improvements could yield. So whenever you're trying to mediate a situation or you're dealing with people who are in conflicting views, I think the most important thing to do is look for common ground. So what kind of common ground can we find between these two camps? I think everyone wants improved software quality. Everyone hates bugs, and the process of debugging is always very painful and time-consuming. Improved software efficiency, software that costs less to make and software that costs less to develop and share. A lack of difficulty in training and education of people who you want to use your software or who you want to be able to develop with your programming languages or your APIs. A reduced investment in basic computing. Every business would like to have a free payroll package so they don't have to take that off of their overhead out of their bottom line. And two that I've highlighted down here because these are the most important to me personally is rapid technological progress and rapid scientific progress. So what software development models are going to support these commonalities the best? And what exactly is the public domain and how could it play into this? Well, the public domain is basically no rights reserved. When you place something in the public domain, you're basically putting it out there without any copyright on it, without any claim of ownership. There's no legal restrictions on use at all. Public domain does not impact the 4 primary freedoms. Those are still preserved by public domain content. Since the content isn't owned by anyone, there's no one there to take away your freedoms. No one's freedoms are restricted. That's a little bit different than the GNU project and the GPL in that corporations and people who would like to develop commercial software, their freedoms are restricted. You're actually placing restrictions on them and saying that there's things that you can't do. And that personally doesn't sit very well with me. I kind of consider myself a libertarian, and I don't think that anyone should kind of impose their will on others and take away people's freedoms. So I have always had a hard time putting my software under the GPL, knowing that I was restricting people from doing things that could benefit everyone. And because no one's freedoms are restricted, public domain is much more friendly to corporations than the government, obviously, because anyone can take that source code, anyone can improve it, anyone can share it, and anyone can develop based on it. It's eventually where everything ends up anyway. Software that falls out of copyright after the term of copyright is over is public domain software. Initially in the AI lab, if you actually look at the environment and how software was treated and how it was considered, it actually was considered public domain. It wasn't someone's property. It wasn't something you had to go ask to share. If you would have just taken it, that wouldn't have been a problem. But most importantly, the idea of public domain involves a paradigm shift in the way that people think of software. Instead of thinking of it as something that holds a lot of value that has to be licensed and you have to negotiate with other people to use and something that you're doing a great good by sharing with others, I think we should think of software as like a discovery, like mathematics. It's just something that happens to exist in the world. It just happens to be the best way to process information. So if we can start thinking of software as not something that has value and that should be sold and contractually negotiated, I think we'll see a lot more rapid progress. We'll see a lot more software out there. We'll see a lot more people using it. And we'll see a decline in the number of people who try and charge for it and try and charge exorbitant amounts for it. So went through this a little bit. Why is public domain better than open source or the GPL? Again, no one's freedoms are restricted. It's much more efficient. Programmers don't have to spend time trying to understand licenses. The GNU GPL is a pretty easy to read license, and it was specifically written that way. But if you read the licenses of some other open source vendors, like the IBM license, they're very complex, and you almost need advice from a lawyer to really understand and understand how you can use the code and who you can share the code with and what kind of liabilities you're opening yourself up to if you copy code from one of those open source projects. I really think that programmers should spend time programming. I really hate the law. Like I said, I'm a libertarian, so every paragraph of law is something that I really just cringe at. Unless duplication of work is necessary. Well, one of the things that people tend to do when they're faced with a license they don't understand, or they have too many licenses that span their work to be able to do things like relicense it or really get a good grasp on what can be done with it, is they tend to re-implement. And re-implementation is something that takes a lot of time, and it's very plagued with the possibility of lawsuit and other problems and legal entanglements. So it's best to avoid re-implementation, not only for the legal problems with it, but also because I think it's a waste of time. The thing that's best about public domain, I think, is that it's the lowest point in the legal landscape. I'm sure many of you are familiar with this phrase I have quoted up here, that information yearns to be free just as sparks fly upward or water seeks the lowest point. All information eventually becomes public domain. So why not skip the process of becoming public domain and just go right to the point where it seems to naturally flow to where it naturally wants to be? So we talked a little bit about license complexity, the fact that some of the licenses are getting multiple pages long, involving many legal teams. Every company seems to have its own license, and there's more and more complexity in licenses these days. It's one of the major problems of the open source movement. People can't necessarily tell without legal advice if they can share the code or how they can share the code. And anyone can and does create their own license. I spent a number of years on a mailing list called License Discuss for the Open Source Institute, where people would basically propose licenses to the list and ask for discussion on them in terms of do they meet the OSI guidelines or the things that they could get certified as open source. And what we found is that amateur licenses that are not even legally valid, things that would say, you can use my code, but you can't oppress women in your day-to-day life if you use my code. Or you can use my code, but you have to support Free Tibet. Would get proposed to the list. And what do you do if that license isn't proposed to the list, but just went ahead and posted on the internet as a license on source code that you find? It's really not in a position you want to be in to try and judge if a license is legally valid, even though it seems if it's not, in order to try and copy code. And what the Open Source Institute found is that they couldn't just keep up. There was a time when there was as many as 2 new licenses every week being posted to the list. So on top of all that, you have legal diversity across just different jurisdictions. What's valid licensing in Europe is not the same as America. And as we get into a more global development model, as more countries get high-speed internet access, it gets more and more complex. And the laws keep changing with lobbyists and groups like the WTO trying to enforce American copyright and values on other nations. So really it broke down to 5 major types: the GPL, the LGPL, BSD, MIT, and Mozilla. And if you go out and you want to try and find code that you can include in your project to save you some time, Trove categories can be helpful. Things like SourceForge and FreshMeat use Trove to basically categorize licenses, code underneath licenses so that you can search and find the kind of code that you need. But more license complexity is needed. We already have all these licenses, they're difficult to understand. And what we're finding is that things like Richard's success, as he highlighted with TiVo, is a major problem. When you legally find a way around someone's license that it agrees with the letter of the law, but not necessarily the nature or the spirit of the law as they wrote it, they tend to get annoyed and they try and find ways to keep you from doing that. They come out with a new version of the license, more restrictions, which inevitably leads to more complexity. We have a lot of new things coming out like DRM, liability changes as the internet has become more popular and more people are paying attention to it. A tremendously larger base of people who actually write code and have their own interests and their own desires for licenses. Complex situations on where code is actually running and who has it, like virtual machine-based platforms, web application service providers, and grids and clusters, and licensed content included with applications, things like Google Maps. And if you don't own the map, and how much of the software is actually licensed to you, and is it okay to use their API in your program, and if you can't use the API, can you use the content as well? And we've been finding a blur between hardware and software with things like EEPROM, and if I buy a computer from a vendor, am I allowed to look at the EEPROM? And if that prevents me from booting a certain operating system, am I allowed to remove it, or am I even allowed to read it? So as I said, the Open Source Institute had a large number of problems trying to deal with these complex licensing issues that were starting to emerge, as well as just the fact that there were so many competing interests and all the new people who kind of rushed to software development during the dot-com boom. Even today, right now, the Open Source Institute has 59 preferred licenses on their homepage. And if you can imagine going through a major project, a major piece of source code, something like, say, an Office suite, with code under 59 different licenses to try and determine how you can package it and what you can do with it in a Linux distribution, you can see that that's a pretty complex problem. License changes mean new review is needed. So every time an author releases a new version of the license, you have to go through and make sure that the license complies with everything you've done and everything that they've done. And since it's contract law, they can not necessarily retroactively apply things, but they can make things difficult for you in the future. As you release new versions, say you have to append a security patch, you may have to find yourself underneath their new version of their license. And I've always found that licensed authors are not shy about new versions. We've seen 30 or 40 versions of some licenses in a 2-year time span. So OSI has been trying to convince people not to write new licenses that are not needed. Pick one that has the kind of basic features that you want, the kind of basic structure, and try and stick with that license. It seems to work pretty well, but like I said, there's still 60 or more licenses out there that are frequently used. We've got worse problems on the horizon. When is knowledge representation of derivative work? Things like the semantic web are coming out where people are trying to parse things to RDF. Hopefully source code will eventually be parsed into things like RDF where we can automatically download source code and include it in programs. So what do you do when source code and its format as data become kind of intertwined, and how does licensing affect that? When you're running an ASP program like Google Maps or something like that, which has become extremely popular, when is the ASP actually running it, and when you are, and where is the data, and who owns the data? And then distributed processing applications that have modules and code that automatically replicate and download, folding at home and those types of applications, who's responsible for the licensing there? And how does that work with things like the GNU GPL's restrictions on distributions and source code sharing? At the same time, programming is getting much easier. We've seen the massive API introduced, things like Java, which have complete networking toolkits, complete cryptographic toolkits, complete data structures of basically every type of data structure that's ever been invented. PHP is very similar. Massive internet repositories are becoming popular, like CPAN, where source code is automatically downloaded. It's not very easy to put licensing restrictions on what you download from CPAN. New, even easier languages are coming out, like Python and Ruby on Rails, which have even more complex problems with licensing. So as free software has become mainstream, it's become like the best way for someone just out of college to get a job. So they want to write free software, right? And they haven't necessarily been exposed to the same culture that most of us have, been in it many years. So what do they do about licensing when they're not fully educated about it? It's the easiest way to learn new skills. If you want to learn how to program, well, everyone will tell you, sit down and start a project, write a text editor and something like that. But as the number of open source projects out there proliferate, and we see more and more source code and more licenses, it just gets more and more complex. Companies are starting to flock to free software and open source because it's easy to support something like a blog or a website that you want to set up yourself without actually really investing significant income in. Internet startups that need to start on small amounts of capital are really using a lot of it. And people are even looking to writing open source projects as supplemental income, which when you get into that, you may not necessarily license the code, but you can sell documentation of books and so forth, which can really complicate the sense of how do you limit competition when other people are doing that. So about the same time when a lot of people were coming to free software and becoming more focused on it and getting involved in it, the FSF as a group became a lot less focused on the GNU project, which was actually a full replacement operating system. Back in the 1990s, if you wanted to get involved with the FSF, you'd go to their website and they'd have a list of all the programs that they needed in order to have a complete and free operating system. That's no longer the case since Linux and GNU plus Linux have kind of emerged on the scene. There's less interest in focusing on getting a complete operating system and actually directing the community to write specific portions of code as there is on trying to address all these complex licensing issues that are coming up, advocating free software to all the companies and new types of software that are emerging, and basically just educating people on what a license is and why software should be free and why it's important to have access to it. But now what we have is that free OS coordination is completely split between commercial interests and the Free Software Foundation. We have, GNU plus Linux and all of the distributions that are of GNU plus Linux, the BSD distributions, and even new operating systems emerging like React OS. And with that split, we're getting even more and more duplication of work. We're seeing a lot of programs forked in order to avoid license conflicts. Tremendous numbers of re-implementations of simple things like editors, mail clients, graphic editors, and IDEs, and so on. If you actually go to the web or something like FreshMeat and you search for some of these basic applications, you can see hundreds, even sometimes maybe 1,000 different versions of them if you actually search on the Windows platform as well. And a lot of those are nothing more than the inclusion of a component in a basic application structure. No actual code writing, but code is produced and it's licensed and it's made available. So how can we better spend the time that we're producing all these thousands of applications with? Well, I think number one is innovating. The free software community actually tremendous amount of innovation. Things like distributed hash tables and stuff like that come out of the educational sector almost always emerge first as free software. The peer-to-peer revolution, I think, really emerged from the free software community. But right now, I think we're spending so much time re-implementing things to avoid the licensing conflicts that's really getting degraded, and there's a lot less of that going on. We aren't writing as many free software applications to replace, commercial applications, to do functions that free software applications don't exist for. We're not doing as much algorithm improvement. There hasn't been a lot of new search algorithms. There hasn't been dramatic improvements to some of the optimizations of the compilers and the different languages and things that we would like to see. For some examples, you can look at some of the new chips with Altivec, some of the IBM chips and some of the MMX code, places where free software applications could benefit from those types of basic structural architectural changes in microprocessor design where most projects just aren't picking that kind of thing up. We could be writing code for emerging sciences like bioinformatics and grid computing, or even doing things like ERP, payrolls, business efficiency increasers. And what it all comes down to is what do we want to do? I'm certainly not going to tell you you have to go write an ERP system if you want to write another editor. But is the goal for most of us what Richard said, that all software should be free? And to me personally, that's not the primary motivation for me writing free software. It's not as important as I think other things like rapid technological and scientific advancement. I'd really like to travel into space. I'm a huge fan of Richard Branson and some of the space projects and stuff like that. And if we could get NASA kind of sharing more of their code and working with them to produce code and that kind of thing, I think that we could kind of push that ahead if everyone had access to some of the software and some of the things that are going on there. Reduce computing costs. Cheaper projects, cheaper products, and higher wages would all result if companies spent less money on software. In economic debates between do you have all shared code or do you have things that are actually sold, you always find a mixed model. There's usually a basic level guarantees like healthcare, nutrition, shelter. People will make sure you don't starve to death as part of your government. Higher levels require competition to get to. Privatization of most companies in the commercial sector, and limited scholarship for advanced degrees. Not everyone goes to school for their entire life. You have to compete if you want to get there. And some nationalization, things like mining and oil. So what would a mixed model look like for software? Hopefully what I would like to see is basic infrastructural code, the stuff that we're writing over and over and over again, be public domain. The more complex software, some of the newer stuff, allow that to fall under the copyleft so that the copyleft policy can actually force other people who want to work in that area to release their code. But what good does the GPL really do at the base of, say, data structure implementation, where that code is already free and everyone already has free copies of it? The copyleft doesn't provide a lot of value. So if we could kind of solidify on a small number of versions of, say, data structure libraries or basic system libraries or even a system operating kernel, we'd spend a lot less time on that area and we'd be able to move up into more important things. There may be, justification for commercial products at the very high end, things like specific research in medical areas and things like that. Am I writing an operating system right now? The short answer is no. The long answer is yes, I am. What I'm trying to do is come up with a Linux distribution that is, at its core, all public domain software. So I've been re-implementing the basic Linux commands, some of the basic libraries, and I've started on a small kernel. that's basically completely written from scratch, and it's going to be distributed as public domain. The idea being that if we can get one distribution out there, it'll provide kind of a escape hatch, pressure release for everybody who's having struggles with this kind of problem. Hopefully, it'll be a step-by-step replacement. I'm not going to hold it off until I have complete public domain. Ports like package and patch management will be available. And I'm also trying to put together code repositories as I do this, RFC replicas implementations and cryptographic code. So what's stopping people from participating in this kind of stuff and doing public domain? Companies, the revenue models still work. Software that's not fun to write. There's support concerns, for things like TiVo. If you modify your TiVo code and your TiVo no longer works, should you be able to send it back and get it repaired? Should you be able to have them come out and help you fix it? In the educational sector, there's really an identity crisis in American schools right now. Are they a public institution to educate people, or are they a research institution to do research and generate funding and income from that? Are they there to spin off, technology transfer in companies, or are they there to educate students? A lot of schools are becoming very secretive about their source code, their software projects and stuff, because they're trying to spin them off into commercial companies. There's extensive competition for government grants and things like that. Scientists are competing with each other, so they don't want to share their source code. One of the more complex things, I think, is that grants, you basically have to have some kind of metric to determine, well, how useful is the software that these doctors have written that we've given them a grant to develop? For example, the NIH or someone like that. And right now, it's really based on two things, usage and reputation. As an example, I wrote a sample size calculator for basically clinical trials with some researchers when I was at the University of Florida. And I tried to convince them to put it under the GPL and distribute it, and they weren't willing to do that because they said, when we apply for the grant that supports the statistical research that involves, funding the mathematicians who develop these models, we have to provide some metric of how many people are using these models, how useful are they worthwhile? And what they were doing is basically counting web hits for the number of times it was run. So even though it would be more efficient to run it on a local computer and basically distribute the source code so others could look at it, it was kept on a server so that they were able to protect and provide metrics for their grants. Again, they also have to protect their reputation. So just like TiVo, if someone modifies that software and still cites it as useful, and they modify it in a way that produces inaccurate results, it's a major problem. There's cryptographic solutions to that. TiVo code verification is a great example of that. Basically what TiVo is going to do is, a checksum of the source code, a digital signature verification. If it's not there, it's not going to run. There's a lot of similar ways that you can do that. Digital signatures of the output is one way to avoid doing it with the actual source code, so that you force people to go to a server when they want something that's actually, valuable and runnable. If you want to download the code and produce output for your planning and your own usage, you can do that. But if you want something that you publish and you recognize as something that's useful to someone, well, then you have to go to a server that actually has a digital signature infrastructure as part of it that'll, give you a signed output rather than just, a basic output. You can digitally sign your source code as well. Make sure that people are validating that source code. If someone produces an accurate result, you can ask them to produce source code that's verifiable by digital signature. You can even do complete identity protection with PGP keys. And I don't go into that too deeply here in this talk, but I do have another talk where I actually show the structures of software signatures and the different formats of PGP keys and stuff, and actually go through exactly what happens when you sign source code and what kind of packets you produce and how to decrypt and decode those packets. There's also some legal mechanisms available. Trademark law has been very successful. We saw that with Mozilla and the Netscape. Is basically they said that people could download copies of Mozilla and modify it, but they couldn't call it Mozilla after they had modified it. I think that might be something useful for people to look into who are unable to support GPL or are nervous about using public domain software as a format of distribution. Patents I really don't like, and I don't really see how useful an actual patent on source code itself could be, or a source code model, but patenting something like a technique of inserting, say, radiologically active beads inside tumors or something like that, and then being able to distribute the source code because you have patented the actual method of treatment. That's possibly a way that some of these people who can't currently release their source code could. I think it's important to look for alternatives to contract law, because contract law is very, very complex, and always almost always involves really long-term mediations and negotiations in court. Alternatives to copyright law as well. You can do limited term copyrights where you can just say that this software is copyrighted for a period of 3 years, after which it becomes public domain. So why should you as a developer public domain your work? Like I said, it eliminates the need for reimplementation. It's more efficient. There's less versions for other people to shift through. It saves you from having to deal with the complexity of all the licenses, and it saves others from having to deal with the licenses as well. It allows for easier automation. A good example of where this is a problem now is with the Gen 2 eMerge system when it encounters commercial software like the JDK. You actually have to intervene by hand and merge the software in yourself so that you can agree to the licensing terms. I think we're getting close to a point where computers can do some of their own programming themselves. They can assemble major software systems from components, and if all those components have contradicting licenses, it may be prohibitively difficult for them to be able to do that. And placing things in the public domain reduces liability because it's essentially a good faith effort. It's not a contract negotiation like the GPL where you're agreeing to provide something in exchange for something. And again, it communicates a lack of monetary value of software. So how to get involved if you actually want to start writing public domain software, either working on a Linux distribution that we're going to try and do, or if you actually want to kind of help us map out the best way to go and so forth. You're really just starting out. There's not much there yet. But keep in touch and be patient and hopefully contribute some source code. There is a website with limited information, and that's my email address. Any questions? Yes?
I can see why somebody who's currently writing software in the free software community wouldn't be attracted to your approach because your approach doesn't support the notion of eliminating all proprietary software. But on the other hand, your approach seems to share many of the same goals as the open source community. So I'm curious, when you go to talk to somebody who has existing software that they license under, say, the new BSD license without the advertising clause or the old MIT license, and you say, hey, do your stuff public domain instead, what is the major argument that they give you not to do that? What do they not like about your approach?
I think the biggest concern is that when you place something in the public domain, you're not explicitly having people accept the fact that you have no liability, which is one of the major portions of the BSD and the MIT licenses, is, by using this software, you agreed that, and so forth. I find that people are usually willing to do it, though the biggest problem I have is that people they struggle with the complexity of it. Like myself, for example, I have a product I would like to move into public domain, but I can't because one of the guys who contributed patches had unfortunately passed away. And he had contributed patches as GPL. So, how do I get permission from him to relicense that source code? And the GPL prevents me from just taking it, and I could re-implement it, but his stuff is pretty efficient, and to re-implement it, it's such a basic level that I'd have to do it in an inefficient way, and that's not pretty. So, like I said, to answer your question, I don't find much resistance, but the resistance is mainly liability related. Yes?
Well, I've been a Debian developer for many years, and that involves a lot of suffering with licenses and things like that. So I have some perspective on that generally poorly written licenses and poorly selected licenses generally lead to software not being used. Basically, it dies out. And you mentioned some libertarian viewpoint. I agree with that. Why not just let the free market, let crazy licenses die?
Well, like I was trying to demonstrate with the, essentially that pyramid slide, with the public domain on the bottom, the free software in the middle, and the commercial software on the top, is that I think we could have increased efficiency in the market if instead of relying on people's time to sort through that, we allowed them to use their time to program, and we sorted through it by making sure there was good reference implementations at the very bottom, essentially preventing that software from kind of emerging in the first place by having a better solution available. Any more questions? Thanks, everyone.